All right. So yeah, it's the 17th currently. Okay, so yeah, remembering our rules with multiplying fractions. So understanding that we don't cross multiply here. Cross multiplying happens when those are proportions, so if they had an equal sign between them, we cross multiply. So we can like cross cancel, we can simplify, we can multiply across the top and the bottom if you'd like, but whatever we want to do is we want to end up with a simplified answer. And the reason we're doing this today, this is so important for being able to convert between radians and degrees. And I'm okay with you guys using your calculator, however, I don't want you to be completely blind to what's going on, especially when there's variables in there. You have to think a little bit more. So, what do you guys notice? What do you want to do with letter A? Cancel those x's. So let's get rid of the x's because they're on the top and the bottom. Simplify. Yeah, so you can simplify right now. You could write it as this is just 16 over 12, but we can divide those both by what? 4. So this ends up being 4 over 3. And we do like numbers as improper fractions rather than a mixed number. So don't change that to 1 1/3. Leave it as 4 over 3. Now what's going on in letter B? What's happening there? What's the 4x doing? It's over 1. So that's important to realize that the x or the 4x should be on the top, like over 1. So again, like the last time, those x's get to cancel. And then what do I end up doing with the 60 and 4? Just multiplying. So we get 240. And it'd be over 1 or just 240. And again, I'm okay with you guys using a calculator to a point, but at the same time, I don't want you to only rely on that and not have any idea how to do these without. The reason that's so important is because we're talking about radians today, and typically radians end up being fractions a lot of times, but being able to convert between the two, radians and degrees, we definitely need, we need to know how to use fractions. So, we have our degrees that we've been used to, that we went from 0 all the way around to 360. So every little fraction was a degree. So this was our commonly used way to figure out angles. And so one of the reasons why I'm so picky about, like on the last test, I took off points if you didn't put degrees on your angles, because radians, we don't write degrees. So you have to use like the degree symbol, or you can just write degrees behind it. But radians, you don't necessarily need that unit. You'll see them sometimes write radians, but you don't necessarily, there's no like little symbol that goes with it. So, the way radians work, and I know some of you guys have seen it before, but at the same time it's not something you like use every day because it's radians. It's not something you're thinking about all the time. So the way radians work is they're all based upon pi. So again, this is still 0, but all the way around is 2 pi. Now you'll get in the habit where, I think you will, or maybe you start thinking in radians more often. I automatically like convert my radians back to degrees. So 360 degrees is 2 pi. So there is a direct like correlation between these two. It's not like sometimes it's 2 pi. It's, I mean, always is that amount. So if we're talking about kind of like when we did the 0, 90, 180. So we have 0. And again, this ends up being 2 pi if we go back there. Probably the easy one is 180 is 1 pi. So what would the in-between be? It's going to be a half pi, or pi over 2.
Half pi.
and then this one's going to be 3 pi over 2. Try to get the pi out of your head and not think of it as pi, because obviously you're not going to look at them and be like, oh, that's half of a pi, different pi, like that's a quarter of a pi. So now we're totally confused if we're actually thinking in terms of eating a pie. So get pumpkin pie out of your head. Pumpkin pie fans?
Yes. Oh yeah.
I feel like you either love it or hate it, right? You're not like an in-between, like, eh.
Like little green.
Are you an pumpkin pie guy? Just shocker.
I don't hate it, I don't love it. That's good.
All right. So, we'll talk about how to do this conversion, but I do want to set up our main values of radians that we'll use the most. So again, and I'll write them both as degrees and radians. So this again would be 0 or 360 degrees.
Okay.
And then, so in green, we'll do 0 or 2 pi. And so we're going to work our way around our circle and talk about the really important points that we're going to use the most often, because it's possible that just memorizing some of these or just being comfortable with them and knowing the pattern that goes with it is going to be helpful. So I'm going to go around the first time in purple with our normal numbers. So our first degree that we use the most often is 30, and that's the first in terms of size there. So I'm just kind of filling in the ones that we use most often. Oh, and I should have degrees on all of these, sorry.
Yeah, you should.
Take points off. So again, we're going to fill in our radians, the corresponding radians for all of these. And then we'll talk about how to convert back and forth. I'm going to fill in the ones we just talked about, and then hopefully we can kind of logically talk about some of the other ones. So I said this one was pi over 2 up here. This is pi. So think about this for a minute. Are there any other ones that would be logical for you based off of what you see up there? Like, for instance, you understand what 30 out of 90 is, or 45 out of 90, or 60 out of 90. There's kind of like some patterns or rules going on there. Does anyone have an idea? So if this is pi over 2, does anyone have an idea what you can fill in there? So you might have some logic with it, yeah.
45, wouldn't that be pi over 4?
Yeah, because it's half of pi over 2. Does that, I mean, that's logical, yeah. So this would be pi over 4. So this isn't just arbitrary, where we just made up some random numbers to be confusing. So that has like a reason behind it. Anyone think they got the other two? I'd say the 30 is probably a little bit easier.
Is it pi over 5?
So technically it's a third of the way to here, right? So what's a third of pi over 2? Pi over 6, yeah. And if you didn't realize that one, like I said, that pi over 4 I feel like is really logical. This one's maybe a little bit less.
So 60 is pi over 3?
Yeah, that one's going to be pi over 3. Now take a minute to be okay with this and kind of make sure this is logical. A sixth is the smallest of these three. A fourth, a third, we're getting bigger and bigger. A half is bigger. And then we're going to kind of continue this pattern around. So this is 1/3, this one's going to be 2/3. One's 1/4, here's 2/4, so this is going to be 3/4. This sixth is a little bit trickier. 1/6, 2/6, 3/6, 4, 5. This is 5/6. But it makes sense, it's the sixth of the way back to pi. And so 7 pi over 6, 5 pi over 4. 4 pi over 3.
Really?
That's 5 pi over 3. And since I'm not in this unit, I have to think a little bit more. I mean, when you're doing this really, really often, I can probably do that in like in seconds, like get around the whole circle without thinking too much. Because the same pattern always shows up there. So, and if you, again, you heard, like Miss Miller's daughter had like a drawing of this already, like in her notebook, because this is something that like her calculus teacher said, knowing this like well and like maybe having it memorized is something that ends up being helpful because they use it so much in calc. So now, if you're not comfortable with these, and you don't have to memorize this at this point in your life, you're going to be okay without it. We can do conversions between these two. So kind of like when you first start learning another language, like if you first start learning Spanish, every time you hear a word, you kind of translate it back to the word you know it in English. Eventually, it becomes more second nature to you that you can say things without having to say every word and change every word as you go. So it's kind of getting comfortable with that. So we're switching from radians to degrees. We're going to basically multiply by a fraction that is like multiplying by 1. So we want to get rid of the radians. We want to switch it to degrees. So we're going to multiply by 180 over pi. 180 degrees over pi. Because technically that's 1. 180 degrees and pi are the same thing. Pi radians. So this really is just like multiplying by 1. So I want to switch 3 pi to degrees. And again, I know it's not degrees because there's no degree symbol. So I'm going to multiply by 180 over pi, which is why we did the warm-up we did. So the pi's get to cancel. What do you guys get?
I get it, 540.
540.
Yes, sir.
And it's 540 degrees.
Degrees.
Now, we take a minute to think about where 3 pi would be, kind of getting used to this again. So 0, this is 1 pi, 2 pi, 3 pi. We've just gone around the circle twice and another half. So it's 360 and 180 together. So that makes sense that we're back on the axis again. All right. Now you might think you're going to divide by that, but we don't divide by fractions. So what we're going to do is we're just going to multiply by the reciprocal for this one. So we're going to multiply by pi over 180. And again, put this over 1 if you want. Now this one should have pi in it answer. Did this work out nicely?
It says 11 pi over 9.
Right, so if you don't have a calculator that does fractions well, you might have to do a little bit of finagling here. One of the things I'll point out is you can cancel the zeros if you're not really great at, your calculator doesn't do this for you. Sam's gave him the exact answer. So 22 pi over 18, I'm going to divide those both by 2. So 11 pi over 9. Again, we want to leave the answer in simplest form. We don't want some kind of crazy decimal with that. Okay, so kind of get comfortable with those.